All right, thanks for coming along this evening. I think we've got about 5 or 6 things that we're going to do. Quickly revisit the first lecture, reset ourselves. What did we say in the first lecture? How we can reflect on that. I'm going to give you some exam tips, how to write exam solutions. We're going to do a MELTS tournament. This has nothing to do with the home and away season we've already had, and we have a winner. This is now like a knockout MELTS tournament. 13 questions. The first person to get in the lead by themselves will win. Timed, very quick, blip, 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 a review of the entire subject. So make sure you're logged in, ready to go. We'll then tell you about this year's exam, give you a few hints and tips, and then there's a song we made for last semester, and the prizes, give out all the book vouchers to all the winners, the memes, the various MELTS winners, and then a song that reviews the subject for you that we did for last semester. So, quickly, there's where we started. Real world politics in the Game of Thrones. We lost half the class and only you were left, which was excellent. Now, it was really ENG1030. I tried to say that bridge up there is full of electronics components. It's got sensors all over it, monitoring the structural integrity of the bridge. How is it moving? How is it behaving? So, civil engineer, that's a smart bridge, the smartest bridge in the world. Bionic eyes, robotics, chemical plants full of programmable logic controllers. Information and communications technology is everywhere, so this stuff is useful all around. I then said you'd be able to analyse that circuit by the end of the year, and if you put your minds to it, I guarantee you can. 2 cascaded op-amps in a configuration, you probably know, the only trick is we replace the capacitance by its impedance, 1 on J omega C. And we can analyse that circuit, and if you do it, and you plot, this is frequency, and this is what's called the gain of the circuit, the magnitude of the output voltage divided by the magnitude of the input voltage, that's how it behaves. It passes circuits, passes signals in a specific band, and then gets rid of the others. So we might be tuned into our favourite radio station, Gold FM, and we're filtering out all of the other radio signals coming in that are nearby or next to it. And you could analyse that circuit and get that plot. Okay, the unit outcomes were supposed to be an ability to analyse DC and AC networks using appropriate methods, circuit theorems, first-order transient analysis, and phasor analysis for AC circuits. All the things we've done. With John, you looked at the basic principles of op-amps, designing amplifiers in different configurations, inverting, non-inverting, differential. Then you did some bits, some digital logic, different number systems, how do you minimise using Carnot maps and produce a simplified sum of products form for digital functions. And in the lab, you were building things, you were getting used to breadboards and function generators and scopes. You played with LEDs and resistors, capacitors, inductors, and learnt, hopefully, some practical skills which were tested in the lab test recently. So there are a bunch of unit outcomes. The generic skills, the all-important ones, improved oral and written communications, improved personal hygiene, it was a big factor in this subject. Skills in completing a task as part of a team. You learned a lot about Game of Thrones. And, of course, you all fell in love with Daniel Wells. Hey, when did you do that? That's ridiculous. He's fired. That's it. The all-important assessment, you've still got 70% to go, the hurdle. But 30% you've been doing so far is how you're going to pass that 70%. So all the lab tests, the mid-semester, the weekly quizzes, And the new one for this year, the participation. Hopefully most of you have been able to, through either Tutes or Melt's question answering, have been able to get that 2.5%. But the key, the exam is a hurdle. So even if you're 30 out of 30 now, you still have to pass the exam to pass the subject. Or get 45% rather. Don't quite have to pass it, but you have to get most of the way there. We put this slide up, which was Melt's questions answered versus final exam mark. One click, John. The average final mark for students who attempted less than 5 Melt's questions was just under 60%, and the average final mark for students who attempted more than 30 was nearly 80%. And that was in an attempt to encourage you to engage with the subject one way or another, be it going to Tutes, trying to be active in lectures, not passive, and a range of different things. John, what we've got, do you want to talk about the data that we've got now?
So we've got a little bit of data. We've only got the mid-semester test at the moment, but, and I will post this at some stage, we're going to write a paper around it. But there was a consistent 10% better mark on the mid-semester test average if you answered Melt's questions, basically. And this was for any number of questions that you chose as the threshold for the number answered. So,
and we're going to write a paper on it, and you will all be co-authors. So you'll be pleased to know we'll have a 250 author paper.
Must be a
for,
record.
For A squared, E squared. And these were the marks from semester 1, 2013. And you might remember I had a dream, and this was what the marks were going to be for this year. It might not quite be possible now because you haven't all got 30. Oh no, you can still all probably get HDs. Some of you might need 70 out of 70 in the final exam to get there, but that's quite possible. I'll flick these ones over, John. It's easier to do. So exam techniques. This is all important. It's going to show you some model ways of answering questions. Some of you may have seen these, but you won't have seen all of them. This is how you, just some tips. When acidified potassium permanganate is added to a solution of sodium iodide, a reaction occurs. Write a balanced equation for the reaction by writing balanced half equations and combining them. MnO4 goes to something, something else goes to another thing, and stuff goes to other stuff. That's good. Which species is the oxidant in this reaction? The first one, justify your answer. Guess. So lesson number 1 there, honesty. Honesty. That honesty, I think, has been rewarded with some marks there. I'm not sure. It's always best to be honest. Describe what you would observe as this reaction took place. Link your observation to the species involved. Add contents of packet and return to boil while stirring continuously. Simmer on a medium heat for 10 minutes. Sauce will thicken on standing, serves 4. Got some marks there for that. Write a balanced half equation for the reaction at the positive electrode. 2 plus 3 equals 7. What about at the negative electrode? Fork plus shoe equals spleen. And why is the concentration of sulfide ions increasing? Aliens! Damn aliens are responsible for everything weird that's going on around here. So there we go. Graph the overall mass versus time. Explain the shape of the graph. It's curvy, with a higher bit at the end and a rather aesthetically pleasing slope downwards towards a pretty flat straight bit. I guess that's this bit here. The actual graph itself consists of 2 straight lines meeting at the bottom lower left-hand corner of the graph and moving away at 90-degree angle. I believe they're called axes, but anyway. Each line has an arrowhead on the end. Now that is very observant. They read the question clearly and had great powers of observation. So the other hint, read the question carefully. Why is an atmosphere of argon required in the second stage? I'd say it was probably those damn aliens again, them and their illegal moon rock trade, always trying to kidnap all the argon. So there you go. Be creative, be creative. Find X. There it is. Very good. creative. You can read through that. 3K object released from rest at a height of at the foot of the ramp is a spring of force constant, blah, blah, blah. Does the object continue to move after it comes to rest? No, there is an elephant in the way. If you can't do it, change the question so that it's more suitable for you. He changed it to one that this person could actually do, which was good. So remember that. I could read the question. I don't think the answer has a lot to do with the question anyway. Another example, you didn't like the problem, just change it. Use calculus to find the identity of Batman. And if you integrate Batman, T-Bat, you get Bruce Wayne. See this one? Limit as x goes to n1 is infinity. Perfectly legitimate answer given the single data point that was available. The water of the Earth's ocean stores a lot of heat. An engineer designed an ocean liner that would extract heat from the ocean's waters and reject heat to the atmosphere. He thought he had a good idea, but his boss fired him. Explain. Because he slept with his boss's wife. Yeah, that's not a good idea. Notice the name on this one. Is that Jonathan?
Jathan.
I think it might be Jonathan. This one, sketch C, and you've got the coordinates. Show that the equation. Find the values of C. Where does the line L meet C again? Well, here it is here. There's the line L, and so C, we meet again. There we go. Does anyone know the Beer-Lambert law and define all the... Well, apparently this is it. This one was from a circuit subject that I taught up at the University of Sydney in about 2000. Sketch the capacitor voltage versus time, something you might get in this upcoming one. This was the only question that this student answered. And there is the capacitor versus time. Had to pass the student, went on flying colours, multi-billionaire now. I don't know if you can read this one. This is in fact from semester 2 last year for this subject. Question 3, 15 marks. Please answer the following questions in the space provided. List 4 assumptions made when analysing ideal operational amplifiers. The sum of the currents entering the op-amp is 0. No energy is lost through the op-amp. Don't know what that means. The voltage drop through the circuit is all done by the resistors. I don't know what that means. But the final one. Norbert Nadal told his wife she was getting fat by making her solve an op-amp problem with a gain of 20 pounds. There you go. A gain of 20 pounds. Norbert Nadal comes into play, as he should. And again, that student passed. So if you don't know the answer, at least be creative, make something interesting, and we might think that's good enough to get through. So after all those great hints, it is time for the meltdown, the mad meltdown. $100 book voucher. Doesn't matter if you haven't answered them so far. This is the new thing. This is the tournament. So you have to go into the ENG1030 tournament.
He probably has some paper. You might need to write things very quickly.
Get yourselves ready. Some will require writing. And it is timed. You haven't, and like 30 seconds, 60 seconds, or 90 or 120, depending on the question. And as soon as we have someone clearly in the lead, that is the winner. We stop.
Do you want to put up the first question?
Okay, so first is just to test your buzzers. This does not count. Test your buzzers. Make sure we're working.
There's no right answer to this.
So you want me to post that one?
Yeah. I can't post you.
What? Yeah, I haven't put it on. I haven't done it yet. Start quiz. Testing our buzzers. There we go. Got it? Wow. I can see what you know now. There's one thing you learnt in this subject. It's my football team. Very good. So we have about 60 responding. Is that 60 competitors? Okay. So that one doesn't count. You don't have to get it in. Now, if you're not using melts, still have a go. You're welcome to have a go at the questions. Maybe help your partner who is, and you can share the book voucher if you happen to win. Well, I put it up, the first one.
Yep.
Hang on.
You want me to put it on there?
Yes. Go.
You got 30 seconds.
30 seconds. Oh, you'll have to get the pen off onto... There we go. We've got a timer and a gong. What is the resistance in ohms of element 1? You can see the blue line's your timer. Got about 10 seconds left. There it goes. Well, 77 out of 85 got 3 ohms, which is D, the correct answer. All right, good.
Next.
Hang on.
Quick preview.
Question 2. Question 2 is up. What is the power in watts supplied by element 2? Power supplied by element 2. Not absorbed, supplied. So that was B. Minus 36. 36 is absorbed, minus 36 supplied. All right. A lot of people still got that one. Let's go to 3. Yep. What is IX in milliamps? So it's essentially a Kirchhoff's current law at the top node, say. You got 60 seconds for this one. We're being kind. Still got about 30 seconds. Ten seconds probably. These are too easy, John.
They're just roll through them now.
81 out of 87 got B2. So B2 is correct, 2 milliamps. All right, we better make some harder ones. Question 4, go. What is V0 in volts? a current divider. Find I2, sorry. This is 90 seconds, John. Oh, too kind. What's the correct answer? Oh, they've still got 30 seconds, though. How's the leaderboard looking? Oh, what? About 10 seconds. "84 out of 90 got B, 24, which is wrong." No, that's correct. I told you they were too easy for these guys. Question 5. We've moved into op-amp, so we're following through the subject. We've just hit week 3. This might be a test because it was a while ago. So remember the golden rules of the op-amp. V plus equals V minus. No current into the terminals. Effectively just apply Kirchhoff's current law using those rules. Oh, about 20 seconds left. This one sorted a few out. 47 out of 80 had D, 14 volts, which is correct. Non-inverting amplifier, gain of 7.
I'll start with the
Okay. Well, question 6 is going, but it's not up yet, but hopefully you shouldn't be answering it yet. Now, here you go. So another op-amp, but same idea, golden rules, Kirchhoff's current law. But it's a 90 seconds for this one. 22 people still in the running. Everything correct so far. Is that right? Oh, you did it? The answers are split nearly evenly between all A, B, C and D for this one. This has really sorted you out. I suspect it could be... Well, I think you've got me worried now. I think the answer is A, 2 volts. So you could get the answer V0 in terms of V1 and V2. In fact, this was a Meltz question in one of John's lectures. 4V1 minus V2 would be what V0 is. 4V1 minus V2. Plug in those values, you get 2 volts. How many left now?
Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left.
10 left. You know who you are. It's getting tense. Yep, 7's up. What is the decimal equivalent of the hexadecimal number? Too bad. Too bad. It's my favourite hex number. I know this off by heart, this equivalency. I go to bed dreaming of this decimal number because I know its hexadecimal equivalent is too bad. Are you guessing? Don't guess. You know how the number systems work, hexadecimal base 16. You run out of digits when you get to 9, so you go A, B, C, D, E, F. About 15 seconds. Oh, you can't use calculators. No, if you know how to use a calculator to do it, good work. You should just know 16 cubed. It's 2 to the 4 to the 3, it's 2 to the 12. Look. 2 to the 4 to the... Yeah. Okay, well, 58 out of 81 got the answer correct. C, 11,181. 11181. Never forget it. Should we check? Yeah.
Ooh, down to 6.
6 people left. Oh my goodness. Question 8. What is the decimal equivalent of the 8-bit 2's complement number? 2's complement number. 1000111. 2's complement. System that represents positive and negative numbers. First, I should have put -7 down as one of the detractors. I didn't put it. Traditional sign bit based. Whoops! Forgot to lock it. 36 out of 64 have the correct answer. A, -121. You convert it exactly like you do before, except the most significant bit is negative. So it's negative 2 to the 7. Plus 4, plus 2, plus 1. What are we up to? 5 left. We're up to question 9. The groans. You don't like Carnot maps? Oh. Maurice Carnot from Bell Labs. So there are multiple simplest representations, but only one of them is in the answers. Only one of the simplest possible answers is in the options. But it's not unique, this one. Seems long.
Oh, yeah, no.
Yeah. Should I lock it early? Oh, there we go. So it was B. And 64 out of 74 got that it was B. Well done. So what's this one? Question 10. Now we've moved to week 8. A little bit of nodal analysis, perhaps. Don't look back through your notes. We have done it before, yes. I didn't want to draw new diagrams. Don't think so.
Didn't get it. Didn't get to answer.
Oh. About 10 seconds. The correct answer was B, 1.5 and 50 out of 74. 50 out of 74 got that one. So it's a good hit rate. You're doing very, very well. Here's question 10. We're into week 9. What's the Thevenin equivalent resistance? Only 3 left? Oh, this could decide it. Don't panic. It's only a $100 book voucher. I panicked so much I forgot to ask the question. Which one is it? 11. Shh. There we go. I know you were answering it. I must have asked you. Question 11. What is the Thevenin resistance in K ohms?
Guess they want to split it or they want to leave the chance.
This could be it. That'll be it.
Yeah, that'll go like.
Well, it pretty much has to be.
Let me know.
It was. So the answer was D, 2 K ohms, and 52 out of 74 got that correct. Okay, so we'll just see if we were down to 3 on the last one. I'm trying to get out of it. Still 3 left. Gee, all right. Here you go. Now, stay calm. You have the technology. You have the power. This was actually, you could just use I equals C to V by dt. You do your analysis of an op-amp. V plus equals V minus. I equals C to V dt. You can do KCL at that top node. KCL at the negative inverting input. But there's a capacitor there, so C to V dt. So maybe that's not just a gain at 6 or something in this circuit, does something else. So very evenly spread across all possibilities so far. Surely we can get a winner after this one. This is really
Ooh,
pasted them. Oh dear, oh dear. The answer is C, 10 sine 10 t. And only 15 out of 70 got that correct. That's a differentiator, that circuit. Differentiates the input signal.
we have a winner.
We have a winner!
But his name is anonymous, so change your name.
Well,
Oh, it must be him.
who?
Someone's trying to change it.
They think they've got them all right so far.
Yeah, if you think you've got it all.
Woo!
We have one person on 13.
Okay. 12?
12, sorry, yes.
All right. You can find out, can't you? You can dig back in and find out. And we'll call out your name later when the prize comes. But fantastic work. We've just reviewed the entire subject. We did have one more up our sleeve, an equivalent impedance, but we'll move on.
No, it wasn't Kezia. It's someone else. If you were up the top, your name is anonymous. Change your name on the leaderboard. But keep going.
We'll look it up. All right, the final test. The final exam. It's again a 3-hour exam. I think that's all that's relevant there. No calculators, the same as usual. Don't forget to put something there or we won't know who you are. Don't put anonymous. That just shows you same structure as the one we worked through. 10, 10, 15, 10, 10, 15 adds up to 70. So when you're thinking through how much to spend, how much you should be spending on each question, remember it adds up to 70, not 100. There's a formula sheet. Quiet, guys. Shush, shush. Shush, shush. You've got that online, so you can see what you can have to remember and what you don't have to remember. Even has a few angles, because we realise you haven't got your calculators with you. Question 1. Should I say if you can do the Semester 1 2013 question 1, I'm quite confident you can do the Semester 1 2014 question 1. It is simple nodal analysis, 3 nodes, current sources only, like that. Simple mesh analysis, 2 meshes, voltage sources only, like that. And a harder one with dependent sources and voltage sources, but where you don't have to solve the equations, you just have to write them down. Question 2, superposition, Thevenin and Norton. A superposition with 2 independent sources only, much like that. You then have to find a Thevenin equivalent circuit, and then there's a more conceptual one on Thevenin and Norton. See if you get the idea. Do you want to talk about op-amps briefly, John?
Yep, so it's basic op-amp stuff. There'll be some wordy type questions, and you'll just have to do some straight out analysis of a couple of op-amp configurations. One might be quite easy, one might be a little bit harder. Question 4, again, fairly standard. If you have a look through some of the past papers, we just want to make sure that you have all the theory down pat.
Well, so question 5, capacitors, inductors, transient analysis. One's a simple circuit analysis. You need to know I equals C to V by dt and V equals L di dt, and be able to do a KVL or a KCL, just taking those things into account. Then it's more standard DC steady state analysis and how much energy is stored in different components. And then a transient analysis of circuits with sources, resistors, and either a capacitor or an inductor. Just one element, because that's the only thing we did transient analysis for. So maybe a bit like that example from the Semester 1 2013 exam. Finally, the AC steady state analysis. You'll have to find an equivalent impedance, perhaps something like that. And then with a simple circuit analysis in the phasor domain. Replace everything, one on J omega C's, J omega L's, find a current, find a voltage, but the circuit that you do that for will not be too complicated. You should all get 70 out of 70. Clearly, I've seen how you've performed today, and you've got what it takes. Now we have some prizes to give out, and then we'll show you our song. Now we have, I'll show you 5, and then we're going to vote not with belts, we're going to cheer as loudly as we can. So remember, there's that one, there's that one, there's that one, there's that one. He did put another one up, I had to remove it. And that one is a very new one. Wife sends him mixed signals, doesn't know Fourier analysis. So I think we're going to start with this one, and I want to cheer if you think this should be the winner. So let's go. 1, 2, 3. All right. Now for this one. Now this one. And this one. Whoa! I think we have a winner. Do you agree? I think that was clear from the noise. Is that Jared? Is Jared here? Do you want to come down, mate, and collect your book voucher? Well done. Congratulations. Now, there's only one problem. I got my assistant to go and do this, and instead of getting $100 each, she thought it was $100 in total between 6, so it's only $16.66. No, it's $100. Well done. Congratulations. Beautiful. Where's the photographer? Oh, shit. No, well done. That's good. Do you have a favourite, John?
I think I like that one. I like Moses' one.
You like that one too? Oh.
You
Is Ollie here? Mate, I'm going to give you one then for my preferred prize as well. And because no one else cheered for that, where did I just put him? Here. Well done, mate. There you go. That other one you put up there, man. I had to get rid of that. That's it. Well done. Okay. Now, the randomly selected MELT survey completion prizes.
All right, so Yifei Du wins the one for who attended lectures and used MELTs. Is he here? Or he or she?
Good. Well done.
Kyle Craig wins the survey prize for a person who did not regularly attend or use MELTs. Is he here?
Probably not.
I'll email him.
No. Do you think you should get it or just give it out to someone else?
Give it out to someone else? We'll see.
You had to be here to do it.
And Alan Sim wins the overall MELTs.
What was your name? Level 9 Manic Aquamancer or something?
Level
That's him. That's it. What a name.
God, it's Jamie Evans 4.
Did you just change it?
Jamie Evans
take
4,
that
I
back.
swear.
No, well done. So top of the MELTs leaderboard. Well done, Alan. Got about 60 correct throughout the semester, so a fine effort.
The tournament winner.
Thank you. Thank you.
The tournament
Thank you.
winner was YZHU.
Now,
Oh, well
I was going to say, if she wasn't here, that would be a really worrying thing, because she's won the MELTs remotely. Well done. Very well done. That's unbelievable. That's impressive. Clearly, we'll keep out for 100% on the exam. That's right.